Yes, ma'am.
Okay. So last lecture we have started with complemented lattice. We have seen more examples based on it. So now we are going to see the next point, and that is, I think, after this, yes, after this we have seen that is complemented lattice. So today we have to see second type of lattice, and that is distributive lattice. So based on this, they may ask you a question like explain types of lattices. In that, you have to first explain first type as a complemented lattice and second type as a distributive lattice. Okay. So today we are going to see what is distributive lattice. A lattice L star XOR is called a distributive lattice if for any three elements A, B, C belongs to L, A star in bracket B XOR C. This is equals to A star B XOR A star C, and A XOR B star C. This is equals to A XOR B star A XOR C. So here just we have applied distributive property on three elements of lattice, and those three elements as A, B, C. So here we have just written what is the distributive property. So we can say that a lattice which is satisfying distributive property, that lattice is called as distributive lattice. And for example, you can consider any three elements, those belongs to lattice L, and then you can apply distributive property. Now check here, in this first property, what we have done? We have taken star outside the bracket and XOR inside the bracket. Now we have to apply this star operation over this bracket. So we can write A star B as a first bracket, then XOR A star C. So here we have applied distributive property. So likewise, you can extend the position of XOR and star operation. So now XOR operation is outside the bracket and star operation is inside the bracket. So here you have to distribute this XOR operation over this bracket. So A XOR B star A XOR C. So in both the ways we have checked. That's why this is a distributive lattice, because this is satisfying distributive property. So again, they have given here. In other words, in a distributive lattice, the operations star and XOR distributive over each other. Yes, that is why I have written here. This star operation is distributive over this XOR operation, and in the second case, this XOR operation is distributive over star operation. So this is the definition for distributive lattice. Have you understood meaning of distributive lattice?
Yes,
Yes,
ma'am.
ma'am.
Okay. So here they have given some examples. Show that lattice given by following diagrams are not distributive. Okay. So here we have to prove the given lattices are not distributive. Okay. So here in the first case, five elements are there: A1, A2, A3, 0, and 1. Okay. So we can apply distributive property here as first we can consider A1 as a first element. So A1 star A2 XOR A3. On remaining two elements, that is on A2 and A3, we can apply XOR. So likewise, here we have applied for three elements. A first element we have taken as A, then star operation, and for these two elements we have applied XOR operation. So likewise, here first we can consider A1 star, and for remaining two elements we can apply XOR operation. Okay. So now we have to check whether LHS is equals to RHS. Now consider this is LHS, that is A1 star A2 XOR A3. This is our LHS. So what is value for A2 XOR A3? Look at here. A2 XOR A3. So what would be the value for this operation?
A3.
XOR. This is XOR operation. XOR means for least upper bound. So A2 for A2 and
A2.
A3. Yeah, A2. That is correct. So value for this bracket is A2. Now A1 star A2. A1 star operation A2. So again star is equals to greatest to lower bound. So what is greatest to lower bound for these two elements?
A2.
What? Greatest to lower bound.
Zero.
Correct. So here value for this LHS is equals to 0. Now we have to apply distributive property. So if you apply distributive property, it becomes A1 star A2. This will be first bracket. Then XOR A1 star A3. This is the second bracket. Now check for RHS. This is our RHS. So A1 star A2. What is value for A1 star A2? That we have find out, and it is 0.
Yes.
And yeah, and A1 star A3. A1 star A3. So again, greatest to lower bound for these two elements, it is 0. Okay. So here we got value for LHS as 0. Value for RHS, it is again 0. So we can say that LHS is equals to RHS. So this satisfies distributive property. Okay. Now we have checked this for pair of elements A1, A3, A1, A2 and A3. Now we have to consider A2 as a first element. Okay. So I have written here A2 star. Now whatever two elements are remaining, we have to apply XOR operation on there. So A2 star A1 XOR A3. Now for this we have to check. So first of all, we will solve this bracket as A1 XOR A3. A1 XOR A3. This one we have to find least upper bound for this pair of elements A1 and A3. So what is the value for A1 XOR A3?
1.
1. Yes, correct. Now A2 star 1. A2 star 1. This one greatest to lower bound of A2 and 1. So which one is
A2.
greatest? Is A2. So value for LHS is A2. Now apply distributive property. A2 star A1. This will be one bracket. XOR A2 star A3. This will be another bracket. Now check for value for these two brackets. First one A2 star A1. So value for this
0.
is 0 XOR A2 star A3. So value for this pair is A3. So 0 XOR A3. 0 XOR A3. So least upper bound for this pair of elements 0 and A3. And that value is A3. Now check here. For LHS, we got answer as A2. And when we apply distributive property, then we got value as A3. So here A2 is not equals to A3. That's why this is not a distributive lattice, because for all the pair of elements, it should give you distributive property like LHS is equals to RHS. Value for both the sides should be same. Then only we can say that this is satisfying distributive property. Hence, it is distributive lattice. But here, if you consider A2 as the first element, then for LHS, it is giving answer as A2, and for RHS, it is giving answer as A3. So these both the sides are not same. That's why this is not a distributive lattice. So likewise, we can again consider A3 as the first element. So A3 star. Now on remaining two elements, we have to apply XOR operation. So A1 XOR A2. So first of all, find the value for LHS, that is for A3 star A1 XOR A2. So value for A1 XOR A2, A1 XOR A2 means what? Least upper bound of A1 and A2. So this
1.
value 1, correct. Now A3 star 1. For A3 and 1, I have to take greatest lower bound. So for this pair of elements, that value is A3. So value for LHS is A3. Now apply distributive property. So A3 star A1, this is one bracket, XOR A3 star A2. This is another bracket. Okay. Now check for values of these brackets. First one, A3 star A1 means what? Greatest lower bound of A3 and A1. So what is value for this bracket?
0.
0. Correct. XOR A3 star A2. A3 star A2 means what? Greatest lower bound for A3 and A2.
A3.
A3, correct. So value for 0 XOR A3. 0 XOR A3. A3. So again, yes, correct. So here also value of LHS is equals to RHS. So we can say that this diagram satisfies distributive property for sequence of elements like A2, sorry, A1, A2, A3 and A3, A1, A2. But this is not satisfying distributive property for this sequence A2, A1, A3. That's why this is not a distributive lattice. In order to be a distributive lattice, it should satisfy distributive property for any pair of elements or any sequence of elements. But here one sequence is not giving us proper result. That's why this is not a distributive lattice. Understood how to check it?
Yes, ma'am.
Okay. Now, similar procedure you have to apply for second diagram. So, take time of 10 minutes and tell me whether this one is distributive or not. Better way, you solve this example on page and send that image to me personally or on your group, WhatsApp group. In question itself, they have said that these are not distributive properties, distributive lattices. Okay, that is fine. But we have to find the reason why these are not distributive lattices. Because when they ask you question like this, you have to give this explanation. Then only you will get 4 marks. So for this diagram, first element you can consider as B1. So B1 star B2 XOR B3. This is one combination. Second combination B2 star B1 XOR B3 and third one B3 star B1 XOR B2. Now check whether for all these sequences distributive property is 1. If not, then this lattice is not a distributive lattice. Hello. So first of all, tell me, are we able to solve this example? Have you tried? Okay, no problem. We will solve this. So whatever procedure we have applied for this first example, same procedure we have to apply here. Okay, so consider this sequence of elements B1, B2, B3. So we can apply this one as B1 star B2 XOR B3. Okay, so this is our LHS, and RHS becomes, once we apply distributive property, it becomes B1 star B2 XOR B1 star B2. So now we have to check whether LHS is equals to RHS. If this is correct, then we can say that this is a distributive lattice. And we have to repeat this procedure for remaining two sequence of elements as well. So consider B1 star B2. B1 star B2 is what? Greatest to lower bound of B1 and B2. So what is answer for this? Is what is value for B1 star B2? B1 star B2, it is 0. Okay. Now check for next one. XOR operation is there. B1 star B3. B1 star B3. Again it is 0. Okay.
0.
Yes. Now check for this LHS. For LHS we have written B1 star B2 XOR B3. So value for B2 XOR B3. That is least upper bond for these two elements B2 and B3. What is least upper bond? Yes, what is the answer for this? B2 star B3, sorry, B2 XOR B3?
1.
1. Okay. So now is correct. Now B1 star 1 is what? Greatest to lower bound of B1 and 1. So this answer is B1 because we have to find greatest to lower bound of B1 and 1. And here this lower bound is B1. So for this, for LHS we got answer as B1 and for RHS it is 0. So for this sequence of elements only this is not matching. Means this is not satisfying distributive property. That's why this lattice is not a distributive lattice. It is not required to check for another sequence of elements because for first sequence only this is not satisfying distributive property. Have we understood this example? Hello?
Yes, ma'am.
Okay. Now, next one is one theorem, that is every chain is a distributive lattice. Okay. So, here proof is given as let L partial order.
Hello, ma'am.
Yes. Yes.
Voice is not clear, ma'am. Background voice.
Okay, just a minute. I will see. Hello. Now check it. Is it fine?
Yes, ma'am.
Okay. So here theorem is given as every chain is a distributive lattice. Okay. So now we have to prove it. So let L partially ordered relation be a chain and ABC, these three elements belongs to L. In short, these three elements are part of lattice. Now consider following possible cases. So if you consider any three elements, there would be two cases. First one, A is less than equals to B or A is less than equals to C. And second case, A is greater than equals to B and A is greater than equals to C. So now we have to check if you consider these two cases whether this is satisfying distributive property. So let us take first case, that is A is less than equals to B and A is less than equals to C. So that case is given here A, B, C. This is the sequence of elements and here A is the least element because A is less than equals to B and A is less than equals to C. So now this is the diagram for our first case. Now we can take this distributive property as A star B XOR C. Okay. So value for B XOR C is what? Least upper bound of B and C. So what is the value for B XOR C?
C.
C, correct. And A star C is what? Greatest lower bound of A and C. A, correct. So value we got for LHS, it is A. Now apply the distributive property, that is A star B. This is first bracket XOR A star C. Now solve this first one, A star B. That is greatest lower bound of A and B.
A.
Then XOR A star C. Okay, greatest lower bound of A and C. Again it is A. This was value we got for this RHS as A XOR A and value is A. So LHS is equals to RHS. So we can say that for this first condition it is satisfying distributive property. Now check for second case. So what we have written in second case, A is greater than equals to B and A is greater than equals to C. So here we can say that A is the greatest element and this is greater than B as well as greater than C. That's why we have defined the sequence of elements as A, C, B. So here least element is B and greatest element is A. Now again we have to check whether this is satisfying distributive property. So A star B XOR C. So what is the value for B XOR C? B XOR is C and A star C. Again we have to take greatest to lower bound of A and C.
C.
Correct. So value for this LHS, it is C. Now check for RHS. So here we have to apply distributive property as A star B. This will be one bracket XOR A star C. Now value for A star B. This is greatest to lower bound of A and B.
B.
B. Correct. XOR A star C. So greatest to lower bound of A and C. C. Good. Now B XOR C. That is least upper bound of B and C.
C.
C. Correct. So again LHS is equals to RHS. So for first condition as well as for second condition, this is satisfying distributive property. That's why we can prove that every chain is a distributive lattice, because in the first as well as second case, we have found a chain of three elements as A, B, C, and here B, C, A. All the elements are connected in sequence. That's why this is called as chain of elements. And from this, we can prove that every chain is a distributive lattice. Understood this proof?
Yes, ma'am.
Okay. Now, next theorem is given as the direct product of any two lattices is a distributive lattice. Okay. So here they have not given any proof like such, just given as the proof of this theorem follows from definition of direct product. Because in the definition of direct product of lattices, we have seen if you take any two lattices, then whatever lattice we will get after the direct product, that lattice is also a distributive lattice, because whatever lattices we have taken, those are distributive lattices. म्हणजे काय कुठल्या पण दोन लॅटिसचा डायरेक्ट प्रोडक्ट घेतला तर तो डिस्ट्रीब्युटिव्ह लॅटिस येणार आहे. बाय बिकॉज those two lattices, those are satisfying distributive properties. That's why the result will be also a distributive lattice. So these two theorems are important. Based on this, they have asked MCQ for this second theorem. That is, direct product of any two distributive lattices is a distributive lattice. Okay. Now here, again one theorem is given. L star XOR be a distributive lattice for any three elements A, B, C belongs to L. So here L is a distributive lattice. Now they have provided that A star B, this is equals to A star C, this is one bracket, and A XOR B is equals to A XOR C. And this implies that B is equals to C. So this is given. So now we have to check whether B is equals to C. So we can take for these three elements, we can write A star B XOR C. Okay. So again, what they have said here, B is equals to C. So we can replace this B by C. So now value for this bracket becomes A star C, XOR C. Now, what is the value for A star C? So here C is the greatest element here in A and C. So value for A star C, it is A. So again A XOR C. Then array list upper bound of A and C. Again A XOR C means what? List upper bound of A and C. If you consider this one as a diagram, then A XOR C, value for this one is C only. So value for this is C. Now check here. Now we can apply the distributive property for the RHS as A XOR C, this is one bracket, and B XOR C, this is another bracket. So again, they have said that B is equals to C. So for this first C, we can replace it by B. So A XOR B, this is first bracket, star B XOR C. Now what is value for A XOR B? Look at this diagram. So value for A XOR B?
B.
So that value we have written here. So sorry. So first of all, we have to check for these two brackets. Here B is common in both the brackets. So we can take that common part outside the bracket. So B XOR, and what will be remained in this bracket? A star C. काय केलं आपण ह्या स्टेपमध्ये just whatever elements is common between these two elements, these two brackets, we have taken it out. So B is common, that's why we have taken that B outside the bracket, XOR A star C. So now value for A star C. Is A. So again here this C is replaced by B as A star B. Value for A star B, again it is A. So B XOR A. B XOR A means what? Is list upper bound of B and A. It is B. So here we can prove that if you consider this same equation, one time we are getting answer as C and at another time we are getting answer as B. So B is equals to C. In this way we can prove this theorem. Have we understood?
No, ma'am. Can you repeat?
Yes, sure. So here we have considered A star B XOR C. This is the equation we have taken. So in the first case, we can directly find the answer for this without applying distributive property. So this is LHS. So we can consider its value as A star B XOR C. Now they have said here that B is equals to C. That's why we can replace this B by C. So here B is replaced by C. Now what is the value for A star C? Consider this diagram. So value for A star C.
A.
A. Correct. So that value we have to take its XOR operation with C. So A XOR C. C. So that value we have written here. So value we got for LHS, that is C. Now check for RHS. So here we have to apply distributive property. So that is A XOR C star B XOR C. So here we have applied distributive property. So again, in this first bracket, C is there. So we can replace this C by B because they have said B is equals to C. So first bracket becomes A XOR B star B XOR C. Second bracket we have kept as it is. Now, if you observe these two brackets, B is common in between. That's why we can take this B outside the bracket. So B XOR A star C. आपण काय करू शकतो एकदा डिस्ट्रीब्युटिव्ह प्रॉपर्टी अप्लाय करू शकतो otherwise whatever common part is there we can take it outside. So now if you apply this distributive property here you will get answer as B star A B XOR A star B XOR C. म्हणजे काय सेमच रिझल्ट मिळणार आहे. जस्ट वी हॅव टेकन दिस B outside the bracket because B is common between these two brackets. Now again we have replaced this C by B in the next step as A star B. So this equation becomes B XOR A star B. त्यांनी म्हटले की B is equals to C. That's why C is replaced by B. Now find value for A star B. A star B. That is greatest lower bound of A and B. It is A. Okay. And B XOR A. B. Okay. So without applying distributive property, we got answer as C, and after applying distributive property, we got answer as B. So here B is equals to C. Understood now?
Yes, ma'am.
Okay. Okay, so before starting with the next part, just take a break of 5 minutes, then we will continue. So now we will continue with the next point, and that is Boolean algebra. So this chapter has included two main parts. First one that was for lattice, and second main part is for Boolean algebra. So lattice we have covered. So now we will see what is Boolean algebra. So first we will see definition for Boolean algebra, then its properties. So a Boolean algebra is a complemented distributive lattice. So we can say that this is the next version of lattice. So we have seen what is complemented lattice, what is distributive lattice. So if you take combination of complemented and distributive lattice, you will get Boolean algebra. So a Boolean algebra is a complemented and distributive lattice. So now we will see how we can represent this Boolean algebra. So a Boolean algebra denoted by B star XOR complement 0, 1. So why this is included here? Complement, because in the definition itself they have given Boolean algebra is complemented distributive lattice. So B is for Boolean algebra, star and XOR and complement. These are the three operations. Those are defined on B, and 0 and 1. This is least and greatest element for this Boolean algebra. That's why this is represented as B star XOR complement 0, 1. So same explanation they have given here in this paragraph. So a Boolean algebra will be denoted by B star XOR complement 0, 1, in which B star XOR is a lattice with two binary operations, star and XOR. And these two operations called as meet and join operation. That part we have seen in lattice. The corresponding partially ordered set will be denoted by B partially ordered relation. The bounds of lattice are denoted by 0 and 1, where 0 is the least element, 1 is the greatest element of the partially ordered relation. Since B star XOR is a complemented, and because of this fact, it is a distributive lattice. Each element of B has a unique complement. Unary operation of complementation is denoted by this symbol. So this is the symbol for complement. So that for any element A belongs to B, the complement of A, and that is denoted by A's complement, that also belongs to B. Then only we can say that B is closed under operations star XOR and complement. So here what you have to remember, just definition of Boolean algebra. So how we can define it? A Boolean algebra is complemented distributive lattice. Okay, and then you have to give representation of this Boolean algebra as B star XOR complement 0, 1. So again you have to give explanation for each and every symbol. So here B is Boolean algebra, star, XOR and complement. These are operations. Those are defined on this set B. 0 and 1. These are least and greatest element. Then this is a Boolean algebra. Have you understood definition of Boolean algebra?
Yes, ma'am.
Now we have to see what are the properties of Boolean algebra. So whatever properties we have seen for lattices, all those properties are included here. In fact, some more properties are also added. So we have to see those properties. So can you tell me what are the properties of lattices? We have seen 4 properties of lattice. Has anybody remembered? First property as absorption.
Idempotent.
Idempotent. Then
Associative.
associative. Next.
Distributive.
No, distributive. Okay, distributive. Okay. So properties of lattices in that we have seen. First property
Commutative.
is which one? Commutative. Yes. Idempotent, commutative, then associative, and last one absorption. So same properties we have to repeat here, and again we have to add some extra properties. So a Boolean algebra B star XOR complement 0, 1 satisfies the following properties in which ABC denotes any elements of set B. So here we have taken 3 elements of set B and those 3 elements are A, B, C. So check here. B star XOR is a lattice in which the operation star and XOR satisfies the following properties. So whatever properties we have written for lattice, those are denoted by L1, L2, L3 and L4. L is for lattice and there are 4 properties. That's why first property is idempotent property. A star A, that is equals to A. Now we have to take its complementary property and that is for XOR operation. So keep in mind that whatever first 4 properties we have defined, those are for meet operation, that is for star operation, and remaining 4 properties we have defined, those are for XOR operation and that is for join operation. So first property is for idempotent. A star A, that is equals to A XOR A, that is equals to A. Now second property, that is commutative property. So A star B, that is equals to B star A XOR B, that is equals to B XOR A. Third property is associative property. So A star B star C, this is equals to A star B star C. Just we have changed brackets here. So likewise, we can write this one for XOR operation as A XOR B XOR C. This is equals to A XOR B XOR C. And last property, that is for absorption. So A star A XOR B, that is equals to A. Now we can change the sequence of these operations as A XOR A star B, that is equals to A. So all these 4 properties we have seen with proofs in the lattice. I think you don't have any doubt regarding these 4 properties. Have you understood these 4 properties?
Yes, ma'am.
So this is just included as one part of properties of Boolean algebra. So this is first part. Second part is given as B star XOR is a distributive lattice and satisfies these identities. Okay. So now D1, D2, D3 and D4. So here D is for distributive lattice and 1, 2, 3, 4, these are the 4 properties. So D1 is written as A star in bracket B XOR C. So this is equals to A star B XOR A star C. So what we did here, just we have applied this star operation over this bracket. That is equals to A star B XOR A star C. Have you understood this first property?
Yes.
Okay. Now check for next property, A XOR B star C. So here we have to apply this XOR operation over this bracket. So first bracket is A XOR B star A XOR C. Yes, we have applied distributive property. Now third one, A star B XOR B star C XOR C star A. Okay. So this is equals to, just we have to replace star by XOR and XOR by star. So apply here this star, first star, that is A star B, will be replaced by XOR operation as A XOR B. Then this XOR will be replaced by star. Again this star will be replaced by XOR. Again this XOR will be replaced by star, and star will be replaced by XOR. So this equation becomes A XOR B star B XOR C star C XOR A. So these two equations are similar or same. And last property is given as A star B is equals to A star C, and A XOR B is equals to A XOR C. This one. Now look at the first equation, that is A star B is equals to A star C. So here we can say that A is common from both the sides, so we can cancel it. So after cancellation we will get B is equals to C. So likewise, look at the second equation. A star B is equals to A star C. So again, here A is common from both the sides, so we can cancel it. So what is remaining? B is equals to C. That's why these two equations implies to B is equals to C. So these are four properties of distributive lattice. Understood?
Yes, ma'am.
Okay. Now third part is given as, that is for bounded lattice. So V star XOR 0, 1 is a bounded lattice in which for any A belongs to B, the following properties are hold. So what are those properties? B1, B2, B3. So again, why we have written here B? Because B is for bounded lattice and it is containing three properties as 1, 2, 3. So first property, A is lies between 0 and 1. That is 0 is less than equals to A and A is less than equals to 1. Okay. Now second one, A star 0. So what is the value? What we have said in the first property, A is lies between 0 and 1. So that sequence will be 0, A and 1. If you start from lowest element to the highest element. So that sequence becomes 0, A and 1. So what is the value for A star 0? Just imagine that sequence and you have to perform that operation. Can A star 0?
0.
0, correct. And now I have to write its complementary operation as A is there, replace this star by XOR and 0 by 1. So you will get answer as 1 because we have written here complement. So complement of 0 is 1, complement of 1 is 0, complement of star is XOR, and complement of XOR is star. That part we have already seen. That's why its complementary equation becomes A XOR 1 and that is equals to 1. That is we have written here in the complementary part. Now third one, B3 is A star 1. Okay. So again we have to perform greatest lower bound operation on A and 1. So what is the value? A star 1. So A star 1, here it is given as 1. So now we have to take its complement. So again, for this complementary operation, we have to replace this 1 by 0 and 0 by 1. So A, again this star operation will be replaced by XOR, 1 will be replaced by 0, and again this 1 will be replaced by 0. Have you understood this third part for bounded lattice?
Ma'am, can you repeat again?
Yes. So in the first property, they have said that A lies between 0 and 1. Okay. Second one, A star 0. Answer for this operation is 0, as 0 is the least element, and complement of this is, that is, whenever we have to take complement, we should replace star by XOR, XOR by star, 0 by 1, and 1 by 0. That's why this equation becomes A XOR 1, that is equals to 1. So that equation I have written here in complementary part. Now next equation is A star 1, that is equals to 1, that they have given. So we have to write its complement as A XOR 0, that is equals to 0. Understood now?
Yes, ma'am.
Okay. Now, fourth property is for complemented lattice. So here B star XOR complement 0, 1 is a uniquely complemented lattice in which the complement of any element A belongs to B is denoted by A dash. So this dash is complement. A dash belongs to B and satisfies these following identities. So here this is for complemented lattice. So in the operations of lattices, we have included this operation for complement. So for this complement, we have written C, C1, C2, C3. So there are three properties for complement. So A star, A's complement, this is equals to 0. So we have already seen. So if you take any element and its complementary element, then it should give 0 as an answer for greatest to lower bound, that is for star operation, and it should give 1 as an answer for least upper bound, that is for XOR operation. So always keep in mind that value for A star, A XOR, A dash, that is equals to 0. So now value for this A XOR A dash, that is equals to 1. Zero's complement, that is equals to 1. 1's complement, it is 0. Now third property, A star B, this brackets complement. So this complement operation is applied here over this bracket. So if you apply this complement, you will get A complement, then this star will be replaced by XOR operation, B's complement, and that is written here, A's complement XOR B's complement. Now if you take its complementary part, then we have to replace this star by XOR operation. So A XOR B, this whole brackets complement, so you will get A's complement star B's complement. So these are the three properties for complemented lattice. Have you understood?
Yes, ma'am.
First one.
Yes, ma'am.
Okay. So how we have written this property in the complemented lattice? We have seen if you take any element and its complement, then if you perform star operation on those two elements, you should get least element, and that least element is 0. And if you perform XOR operation on those two elements, you will get greatest element, and that greatest element is 1. That's why A is the element, A star, A dash is its complement. So A star A dash, this is equals to 0, and A XOR A dash, this is equals to 1. Complemented lattice मध्ये आपण बघितले how to check complement of any element. At that time, we are not aware about this A dash. That's why we are using method as A star, then this question mark that is equals to 0, and A XOR question mark that is equals to 1. But here we know complement of A is A dash, that is A star A dash is equals to 0, and A XOR A dash is equals to 1. Understood?
Yes, ma'am.
Okay. Now this is the last property of Boolean algebra. So there exists a partial order relation. This is less than equals to on B such that P1, P2, P3, these are three identities. P is for partially ordered relation, and there are three properties, and those are denoted by P1, P2, P3. So first property A star B. So in the lattice itself we have seen what is meaning of A star B. So this is greatest lower bound of A and B, that is written here. Now its complementary part we can write as A XOR B. So value of A XOR B, it is least upper bound of A and B. Have we understood this first property? Lattice's properties are the greatest lower bound and least upper bound.
Yes, ma'am.
Okay. Good. Just a minute. So here, this is first property for partially ordered relation. In that we have defined A star B, that is equals to greatest lower bound of A and B. A XOR B, this is equals to least upper bound of A and B. So likewise, second property is if A is less than equals to B, this is equivalent to A star B is equals to A, and A XOR B, this is equals to B. Means what? If condition is given as A is less than equals to B, means what? A will be lowest element and B will be highest element. Then if you perform star operation on these two elements, you will get A star B, that is equals to A, and A XOR B, that is equals to B. Now third property, A is less than equals to B. This is equivalent to A star B's complement. This is equals to 0, and this is equivalent to B's complement less than equals to A's complement, and this is equivalent to A's complement XOR B. This is equals to 1. Okay. So if you consider any two elements A and B, okay. Now if you perform star operation, it should give you always 0 as an answer. That's why A star B's complement is equals to 0. So from this we can say that B dash is complement of A. Again, if you consider XOR operation, then A dash XOR B, this is equals to 1. So from this equation, we can say that B is complement of A's complement, or A's complement is complement of B. Just you have to keep in mind that if you perform star operation on any two elements, it should give 0 as the answer, and if you perform XOR operation, then it should give you 1 as the answer. So these three are related to partially ordered relation. So there are total 5 properties of Boolean algebra. So first property, that is based on lattice only. Whatever properties we have seen for lattice, 4 properties, same properties we have repeated here, because in the definition of Boolean algebra itself we have written Boolean algebra is complemented, distributive, and one more word we can add here, bounded lattice. So a Boolean algebra is a complemented, distributive, bounded lattice. So first part is it is a lattice. So whatever definitions we have, whatever properties we have applied for lattice, those are applicable for this Boolean algebra, and that is included in first part. Second part, this is a distributive lattice. So we have written properties for distributive lattice. Third, we have taken word as bounded lattice. So third part covers the properties of bounded lattice. Fourth one, we have seen it is a complemented lattice. So fourth part includes all the properties of complemented lattice. And last part, this satisfies partially ordered relation, and those are included in fifth part. So these are total 5 parts of properties of Boolean algebra. So based on this, you will get question for 8 marks. Write the properties of Boolean algebra. At that time, you have to mention all these 5 types of properties. Do you have any doubt regarding this point, properties of Boolean algebra?
What is the property? Second and third one.
Second.
What's the property?
Okay. Second one.
Yes, ma'am.
Okay. So here we have written A is less than equals to B. Means what? A and B are related by this partially ordered relation. Now A is less than B means what? A will be placed below B. Okay. Just imagine A is placed below B. Now A star B means what? Greatest lower bound of A and B. Final answer. A is placed below B, and if you perform star operation on A and B, you will get A as an answer, because greatest lower bound of A and B, it is A, and least upper bound of A and B, it is B, because B is the greatest element there. समजलं का?
Yes, ma'am.
Okay. So I will tell you that how to remember all these properties. Just you have to remember the definition of Boolean algebra. A Boolean algebra is complemented, distributive, bounded, lattice. Okay, 3 words are important: complemented, distributive, bounded, lattice. Okay, so first part Boolean algebra is lattice. That's why we have taken all the properties of lattices here. Second part, it is a distributive lattice. That's why we have added all the properties of distributive lattice. Third one, it is bounded lattice. So we have written here properties for bounded lattice. Fourth one, it is a complemented lattice. That's why we have written here properties of complemented lattice. And last part, lattice satisfies partially ordered relation. So that fifth part will include all the properties of partially ordered relation. So if you remember in this way, you can write all the properties of Boolean algebra. So have you understood today's part?
Yes, ma'am.
Yes, ma'am.
Now we will take present day, and after that we will stop here for today's lecture. Give me present day. Roll number 1,
Yes, ma'am.
2,
Yes, ma'am.
3. Roll number 3.
Yes, ma'am.
Okay. 4,
Yes, ma'am.
5, 6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Yes, ma'am.
10,
Present, ma'am.
11,
Yes, ma'am.
12, 13, 14,
Present, ma'am.
15, 16, 17,
Yes, ma'am.
18,
Present, ma'am.
19, 20,
Present, ma'am.
21, 22,
Present, ma'am.
23,
Present, ma'am.
24,
Yes, ma'am.
25,
Yes, ma'am.
26, 27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
31, 32,
Present, ma'am.
33,
Present, ma'am.
34, 35, 36,
Ma'am.
37,
Present.
38, 39,
Yes, ma'am.
40,
Present.
41, 42, 43,
Present, ma'am.
44,
Present, ma'am.
45,
Yes, ma'am.
46, 47, 48, 49, 50, 51,
Present, ma'am.
52, 53, 54, present, okay, 55,
Yes, ma'am.
56, 57,
Yes,
58,
ma'am.
okay, 57 present, 58,
Yes, ma'am.
59,
Present.
60, present, 61, 60,
Yes, ma'am.
okay, 62,
Present, ma'am.
63,
Present, ma'am.
64, 65, 66, 67, 68, 69, 70,
Ma'am, 12 is present.
12. Okay.
Ma'am, 19 is present.
19. Okay.
Ma'am, 3.
Roll number 3. Okay.
Ma'am, A57.
57. Yes, I am
Madam,
also present.
A46.
46. Yes, that is also present. So many students are absent today, and your absentee is increasing day by day. Take a note of this. I have already informed to your CC that your present is not up to mark. So we will stop here.